Hello everyone. My name is Kunal, and I'm your physics tutor. And we're actually doing transverse wave. Okay, so we are actually doing transverse wave, and today is our lecture number 4. So let me quickly recap the things कि हमने previous classes में क्या क्या चीजें actually cover करी थी. तो हमने previous classes में कुछ relations define करे थे, right? जैसे हमने कुछ रिलेशन डिस्क्राइब किया लाइक वेलोसिटी ऑफ पार्टिकल इज एक्चुअली इक्वल टू माइनस वेलोसिटी ऑफ वेव इनटू tan थीटा, राइट. तो ये काफी इंपॉर्टेंट रिलेशन था. इसमें हमें पार्टिकल की वेलोसिटी एंड वेव की वेलोसिटी में एक रिलेशन मिला था. फिर हमने एक दूसरा इक्वेशन डिराइव करा था which is actually something look like del square y by del x square, which is actually it will be give you the curvature, which is actually 1 by v square, which is actually the velocity of wave square, डेल स्क्वायर वाई बाई डेल टी स्क्वायर. तो ये सारी चीजें हमने डिराइव करी थी, राइट. एंड फिर से और भी लाइक वेव्स की इक्वेशंस वगैरह देखा था. नाउ इन टुडेज क्लास वी आर गोना डील अबाउट or we are gonna learn about the things which is actually termed as velocity of a wave on string. Okay, so let me quickly giving the heading. So these are actually a recap of the previous lecture. So let's start our today's topic, which is actually termed as velocity of wave on string, right. So हमने यहाँ पे जो भी रिलेशन निकाला था लाइक वेलोसिटी ऑफ वेव, तो हमने अभी तक जो भी देखा था which will be like termed as d by d or something like that, right. But all what if the things is not given or something else is given, so how do you calculate the velocity of wave? So as we discussed in our first lecture, like the velocity of wave is the external property or the external property of the matter, which is actually the term now, because the velocity of wave actually depend upon the elasticity constant of the medium. क्योंकि हमने फर्स्ट लेक्चर में ये चीज डिस्कस करी थी कि velocity of the wave is actually the exclusive property of the medium, right. तो हमने डिस्कस करा था. So let me write it here again here to recall you, and then I'm gonna discuss about this thing. So from lecture 1, right, I'm actually right on that day, is that like the velocity of wave is exclusive property of medium. And why I'm saying so? Because velocity of wave depends upon two things. The first is elastic constant of medium, and the second one is inertia property of medium, right. For that reason, actually the velocity of wave is the exclusive property of medium, because the velocity of wave is actually depend upon the elastic constant of the medium and the inertia property of the medium, right. So now what I'm going to take it as, we are going to derive the velocity of wave on the string. So how can we do so? So let's take an approach. So what I'm doing here is considering a wave traveling along positive x-axis, or we can say positive x direction with speed v. Okay, having very small amplitude, having very small amplitude. Okay, so what I'm assuming here, I'm assuming that a wave is actually traveling along the positive x direction with a speed of v, and having very small amplitude, right. The wave has a very small amplitude. So let's take let's make a diagram here. So for that actually it will be clear. Okay, so what I'm doing here is I'm making an arrangement, right. I'm assuming that there is a pulley. There is actually a string which has a mass m is actually loaded here. Okay, right. And this is actually our wall. And what I'm doing here is I'm actually generate a pulse here. I actually generate a pulse here. So this pulse is actually moving with a velocity v, which is actually the velocity of wave, right? I hope it will be clear to all of you what I'm trying to say, right? I am considering here a system. Basically I am considering here a system, or I basically you can say I set up a system, right? And our main goal here is to find the velocity of the wave. So what I'm doing here is I'm taking a pulley and a string, and एक string के एक end पे मैंने क्या किया, एक mass m को hang कर दिया, and other end को मैंने क्या किया, एक wall से knot कर दिया. Now the things is मैंने string को ऐसा ऊपर करके छोड़ दिया, so it start the wave start and the amplitude is very very less. Okay, so keep this thing in mind कि हमने amplitude बहुत छोटी लेनी है. एंड हमने क्या करा, वेलोसिटी ऑफ वेव लाइक ये जो पल्स हमने ऊपर उठाया तो छोड़ा है, ये स्टार्ट मूविंग इन द rightward direction, right? So what I'm assuming here is like the amplitude is very very small, so it start moving, the velocity of wave start actually moving in the positive x direction with a speed v. I'm assuming that it does v, right? Now if I discuss about the dynamics of the system, so we have like mg mass actually acting in a downward direction, tension is actually acting in the upward direction. So we have a dynamics we get tension is equal to mg, right? Where what is T? So T is actually tension in the string, tension in string. And we are defined an another variable which is actually termed as mu. So mu is actually our mass per unit length, or you can say it as linear mass density. Okay, so it will be like actually kilogram per meter, right? So this is actually the linear mass density, mass per unit length. This is actually our tension in string, right? So the things is, we are actually taking the dynamics of this small part of a string, right? So let me write it here. Dynamics, small part, dynamics of small part of string impulse with respect to wave pulse. Okay. So actually the pulse is stationary, but of the considered string moves in the leftward direction with the speed v. If I'm assuming that there is a car or there is an observer sitting in the car and it is actually moving in the same speed as the velocity of wave. So what he assume here that the considering string is actually moving the leftward direction with the speed of v, right? So let me write it here. With respect to car, or you can say observer, pulse is actually a stationary. Okay, let me write it in a clear way here. So the pulse is actually stationary, right? But of the considered string, which we are actually considering here, moves in the leftward direction. But of the considered string moves in leftward direction, right? With a speed v. Right. With respect to the car, what I'm trying to say, with respect to the car, if I'm sitting in a car which is actually moving with the same speed as the velocity of wave. So what I'm actually, what I am observe here is that the velocity of wave and the velocity of car is actually same. So for the observer, the wave is actually at stationary, right? But of the considered string actually move in the leftward direction with the speed v, right? And particles in element perform circular motion with speed v. I hope it will be clear to all of you. If not clear, I'm again gonna tell you, right? So let me quickly tell you again. अगर चीजें clear नहीं हुई तो देखो. Our main goal here is to find the velocity of wave in this string, है ना? एंड हमें पहले से पता है कि वेलोसिटी ऑफ जो वेव होती है वो एक्चुअली एक्सक्लूसिव प्रॉपर्टी होती है मीडियम की, क्योंकि वो मीडियम पे डिपेंड करता है। वेलोसिटी ऑफ जो वेव होती है वो दो चीजों पर डिपेंड करती है, एक होती है इलास्टिक कांस्टेंट ऑफ द मीडियम एंड द सेकंड वन इज इनर्शिया प्रॉपर्टी ऑफ द मीडियम। नाउ अभी मैं क्या कर रहा हूँ, वी आर एक्चुअली डूइंग अ सेटअप जिससे हमारा velocity of wave calculate हो जाए, right? So what I'm doing, I'm using a pulley here. This is actually our pulley. If you gonna write it here, you can write it. This is actually our pulley, and we use a string and a block of mass m, and I attach one end of the string to the block of the mass m and the other end to the wall. Now what I'm doing, I'm creating a pulse here, and there is an observer which is actually moving to the same speed as the velocity of pulse or the speed of pulse is in the rightward direction. And I'm assuming from the dynamics, I assume that there is a tension T in this string, which is actually equal to mg. And we are deriving and we are describing a new term, which is actually the mass per unit length, which is nothing but the linear mass density, right? Which is actually equal to kg per meter. Now, when we discuss the dynamics in the small part of this string, so what we actually observe. So with respect to the car, the pulse is actually at rest, or you can say the pulse is actually at the stationary. But of the considered string moves in the leftward direction with the speed of the v, and each of the particle is actually doing the circular motion with the speed v. Right. I hope this thing will be clear to all of you what I'm trying to say. Right. So let me try to solve the equation or whatever things, right? So when I zoom here, so what you get? Like let us suppose this is actually our something like pulse or whatever you want. So this is actually our point A, and I'm called it as point B for the small section, right? And it has a mass, it has a length dl and the mass is actually dm. Right. So if I make a circle here, like for the considering as a circular motion, and this is actually our AB. Obviously, this is actually DL and all. So there is actually tension T is actually in this direction, tension T is actually in this direction, right? So and there is actually center, and this both and actually the both of the angle is actually theta, right? So we derive to an equation like there is an things like when we take the component here. So we get the component like t cos theta in the x direction and the minus x direction, and the t sin theta in the negative y direction. So what we get are things actually, we get two things like transverse in the downward direction. And when we're talking about the longitudinal, so the longitudinal get cancelled out because one in the left and one in the right direction, so it will be cancelled out, right? So when we write the net force, the net centripetal force, you can say, because the each and the every single particle is actually moving in the circular path. So we have to actually consider the centripetal force here. So when we consider the centripetal force here, right, which is actually, we all know that it will be actually equal to mv square by r. So m centripetal, right? So it is actually equal to nothing but 2t sin theta, which is actually in the downward direction. And we all know that the centripetal force is actually for the dm mass, because we are considering the length is dl and the mass is actually dm, right? So it will be equal to dm v square by r, which is actually is equal to wait a minute. Okay, wait a minute. So dm v square by r is actually is equal to 2t sin theta. Please give me a moment. Sorry for the delay. वो एक senior आ गए थे. So actually the dmv square by r is actually equal to the 2t sin theta, right? So now how can we write the dm as, right? So the actually dm is nothing but mass. The mass is actually can be written as uh, mass per unit length into the total length, right? So the we can write the mu into L. So mu, and we have a L is actually from the trigonometry, we have a equation L is equal to the r theta, right? So the r is actually our radius and theta is the polar angle. So what I'm going to write here is we have a r, and the polar angle we have here is actually theta plus theta, which is actually equal to 2 theta. So I'm going to write it here is like dm is equal to mass per unit length into the total length, and the length we are going to writing here is the r into theta from the trigonometric substitutions, right? So r into, and here the polar angle is actually 2 theta, and into v square by r is equal to 2 to sine theta. And we all know that uh, r se r get cancelled. And we all know that when theta is very, very small or theta is tending to 0, so we have a formula like sine theta is equal to theta, right? We are just using the trigonometric things here. And we have a relation like when the theta tending to 0, we have a sine theta is equal to theta. So what I'm going to write here, and this 2 get cancelled. So what we get from is mu v square is equal to t, right? And you can say, yeah. So we have, we get v square is equal to t by mu. So here we get v is equal to root under t by mu. So this is actually our velocity of wave with respect to string. Mark my word, with respect to string. Because with respect to an observer, if the observer is moving with the same speed, the pulse is actually at a stationary with respect to the observer, right? Because we are using the relative motion concept. So we all know that the velocity with respect to the observer of anything is considered as zero. Because from the relation like velocity of A with respect to B, it actually is equal to velocity of A with respect to ground minus velocity of B with respect to ground, right? So from that relation, I'm going to write it here. Like with the respect of observer, we get the velocity of pulse is actually at zero, or you can say is actually at stationary, right? Now the next thing is from the relation like mu v square is equal to t, we get the v square is equal to t by v. So this is actually the transverse velocity, or you can say the velocity of wave in the x direction or the positive x direction. Okay, so now uh, we are gonna write it here some more noted point. So let me explain here. Okay, so the velocity we get is actually t by mu, right? So here the two things we get, either the t is constant or the t is variable. Like either we get the tension is constant or the tension is variable. The next thing about mu, either the mass per unit length, right? Either the mass per unit length, which is actually defined as the linear mass density. So either the linear mass density is constant or it is variable, right? So according to those cases, these velocities are actually constant. So if it is constant, we are able to apply like S is equal to Vt. Distance is equal to velocity into time, or the distance is equal to speed into time. We are able to apply if the speed is constant. And when the speed is constant, when the tension is constant and the mass per unit length is actually constant. So we have a relation which is actually equal to S is equal to V. And the second thing is actually variable. So when we have variable, so we have actually two things. Either the acceleration is constant or the acceleration is variable. So when the acceleration is constant, we are able to apply the equations of motion. Equation of motion we are able to apply, and when the acceleration is variable, so we have to use the calculus here, which is actually integration or differences. So this is actually a kind of mind map that you have to keep in mind. What I'm telling you is we get a formula which is actually the velocity of wave is actually is equal to root under t by mu, where the t is actually our tension in this string and mu is actually our mass per unit length, or you can say the linear mass density of the string. Now we have some cases like when is like velocity is constant and when is actually velocity is variable. And what happened when the velocity is constant and what happened when the velocity is variable. So when there are actually four cases when the, or you can say that majorly two cases where the velocity is constant and two cases where the velocity is variable or the speed is variable. So we have actually two term, tension and the linear mass density. So when the linear mass density is variable, then the then the speed is actually variable. When the tension is variable, then the speed is variable. And same things for the constant things. When the tension is constant, speed is constant. When the linear mass density is constant, that is constant. Now the two things we are getting. If the speed is constant, we can easily apply the formula, which is actually distance is equal to speed into time, as is equal to Vt. When the speed is variable, then again there is two things happening. Either the acceleration is constant or the acceleration is variable. So when the acceleration is constant, we are able to apply the equation of motion here. And when the acceleration is variable, so we are able to apply the calculus, which is actually integration and the differentiation kind of thing. Right. So now let's solve some question here, which is actually based on to finding the velocity of wave. But one more thing that you have to keep in mind, that the velocity of the wave is actually the exclusive property of the medium, because it's actually depend on the inertia property and the elastic property of the medium. So let's start solving the question. So let's take the question number 1 here. So actually there is a string. Okay, actually there is a string here, and we have a mass hanging on it, which has actually mass at 4 kilogram, and the length of the string is actually 1 meter. And we have a one more thing is given, which is actually mass per unit length, which is actually called as linear mass density, is actually given 0.001 kg per meter. So you have to find the velocity of wave in this string. So the velocity of wave in this string is actually simply, we can calculate is a root under T by mu. So the tension is actually, from dynamics, we can calculate is equal to mass into gravity. So it will be 40. So 40 and divided by 0.001. So it will be like 40 into 10 to the power 3. So it will be actually 2 into 10 to the power 2 meter per second. So it will be like 200 meter per second. So this is actually our velocity of wave in this string. This is simple, right? But as the level of question rises, you have to face some tough problem. Okay, so just keep, these are actually simple problem. After some time, you will start facing this some tough kinds of problem in which have more and more condition, right? Now let's take, this is actually the second question. So what I'm going to take it here is, let's take this string here again. And this time the length is actually 10 meter. And we have a mass of 5 kg actually held. Okay. And there is a thing given, there is actually given like mass of string is given. Mass of a string is actually given is actually 5 gram. You have to find the velocity of wave, right? So how can you find this? This time we didn't have mass per unit length, or you can say the linear mass density of the string. This time we have only the mass of string is given, right? Okay. So how can we do so? So we have a way, like we all know that the velocity of wave is actually nothing but root under tension by mu. So we have to calculate the tension, which is actually easy. We are calculating with the help of dynamics, which is actually 5 into 10, which is actually 50 Newton. So we are able to calculate the tension. But what about the mu? So mu we have is actually mass per unit length. And we have the string mass is actually given 5 gram and the length is actually given 10 meter. So when we solve this, what we get? 10 to the power minus 4 actually kilogram per meter. Because when we convert the gram into kilogram, so it will be 1/1000, and then we multiply it with the 10, so it will be 10 to the power minus 4. So this is actually our mu. Now just put it into the where now just put it into the given formula, right? So it will be like root under t by mu here, and when we put it here, so it will be like tension is actually is equal to how much? It will be 50 Newton. And it will be like 5 into 10 to the power minus 4, and it will be meter per second. And this will get 10. So it will be like 100 root 10 meter per second. When you solve this, you will get this answer, right? It is actually equal to 100 root 10 meter per second. Okay, so we have a noted point here again. So let me write it here. There is actually a noted point. So as the mass of a string is very, very small, tension in this string is constant and it is actually equal to the weight, right? This is actually a good concept. As mass of string is very, very small, tension in string is constant and it is actually equal to the weight, right? So you have to keep this thing in mind कि जितने भी सारे conditions है ना वो आपने ध्यान में रखनी होती है, otherwise it will be like trouble to understand, and it is actually easy topic, so nothing to worry about. Now let's take a something tough question here. We are actually right now we are considering the string, but now I'm taking an example of rope. What about rope, right? If I'm considering the rope here, so what is actually happening? Let me write it here. So question third, actually I'm taking here as a, okay, let me make it here a clear diagram, right? I'm very bad with drawing. Okay, so now let me draw it here. Okay, wait. So let me take it as a, okay, so let me draw here a rope. Okay, so this is actually our rope, which is actually hanging to a wall, and it has a mass m and a length L. Okay, so you have to find the velocity of wave in this. So how can you calculate? Because this is actually not the string. Here the masses are actually at each and every cross section, masses are uniformly distributed. So how can you able to find the velocity of wave here? So there is a way, right? There is a way. If I'm gonna take it as like at a y distance, so what I'm taking as a, we have to find the velocity of as a function of y, because look at it, in the above mentioned two cases we get a constant velocity, so we are able to apply the formula which is s is equal to vt, right? We are able to apply this formula s is equal to vt, but in this case we are not able to apply the s is equal to vt, and the reason is because we have a velocity as a function of y, and it is actually first we have to find the mass of the y length. So for the full length we have a mass point length is L m by L, and for the y length we have a m by L into y. Now we have a velocity which is actually equal to, we all know, root under t by mu. So our tension is nothing but m by L into g, and mu is our nothing but mass per unit length. So this and this get cancelled, so we get the velocity as a function of y, which is actually root under y into z. Now the second thing is, what what is your comment on acceleration? So acceleration is actually v dv by dy, as we know from the kinematics. So here the root under yg and dv by dy is actually, when you do, it will be like 1 by root under 2 yg. Actually here is g. So 1 by root under 2 root y, right? So it's get cancelled. And what we get the acceleration is actually g by 2, which is actually 5 meter per second square. So here we get that that case in which the velocity is actually variable, but the acceleration is actually constant. So here we are able to apply the equations of motion. And in some cases, you also get like acceleration you get is actually variable. So in that case, you have to apply the calculus. That means you have to use the for like displacement and all. You have to integrate the acceleration and the velocity. And for the next thing, like whenever you have to calculate, so it will be use the then you have to use the differentiation and all, right? So you have to keep this thing in mind. So yeah, okay. So I hope this will be clear to all of you what I'm trying to say. Now there is a question. So I actually want to discuss you all. Uh, on the same question, if I'm gonna ask you is like find time taken by wave pulse generated at bottom to reach at top position. So how can you find in this question? We have a same question in the we have actually the third question in this the ever part. In that one we have a wave is started from there. So how much time it or the how long the wave take to reach the top position? So what I'm gonna apply here is we have a velocity at bottom, or you can say okay. So at y is equal to 0 as we derive here in the above problem, we have v is equal to yg. So at y is equal to 0, we get the velocity is equal to 0 meter per second. That means at bottom we have a velocity of 0 meter per second, and we have an acceleration which is actually g by 2. So when we apply, and we all know that when we have a variable velocity, but we have a constant acceleration, and here we have a constant acceleration which actually is equal to the z by 2. So we are able to apply the equations of motion here. So when we apply the equations of motion here, which is actually the s is equal to ut plus half at square. So we can able to calculate the how long the wave pulse takes to reach at the above position. So let's try to solve it. So we have like acceleration is equal to g by 2. Right, we have like acceleration is equal to g by 2. So from equation of motion, which is actually s is equal to ut plus half of a into t square, and we have a u at bottom is actually 0, and we have a s is equal to l, so half, and there will be like g by 2 into t square. So here we'll get t is equal to nothing but 2 root under L by G. So this is the time taken by the wave pulse to reach at the top position from the bottom positions. Right. So this is actually in second. I hope this will be clear to all of you. Right. So, and one more thing you can do, like how much time to take, like how long the wave pulse to reach at the midpoint, or what is the velocity of the pulse at the midpoint. So you can able to calculate this thing either by integrating, because we all know that velocity as a function of y. So we can use like v square, like v is equal to something like x dx by dt. You can use this like v is equal to dx by dt, and then you use some things to integrate this kind of thing, and then you are able to calculate the velocity. But in this case, from this mind map that we are actually create is actually very useful. This mind map will help you in a lots of things, like what if the velocity is constant, what if the velocity is variable, and the velocity of variable, then acceleration is constant and the acceleration is variable. So what else we can do? Like if I'm gonna asking you in the fourth question, what is the velocity? What is the, let me verify it, right? So what is the velocity from bottom to half of the row? ROP, right? So how can you calculate it? we actually we all know that the v is equal to u plus at. I'm just moving through that concept of obviously, or you can use the third equation of motion, which is actually v square is equal to u square plus 2as. So let me try to move it that one, right? Because yeah, it's easy to calculate. So okay, so v square is equal to, you have u square plus 2a into s, and you have u bottom is 0, as we know from the previous. Acceleration is actually g by 2, and here it will be like L by 2. So this and this get cancelled. We get v is equal to root under Lg by 2. Now let's verify it. So on verifying, how can you verify? We have a v is equal to root under yg, right? And we have to calculate the velocity or the speed at the half of the rope. So the y is equal to nothing but the L by 2. So when we put here, we have what we get? Lg by 2. Right. So these are the things, like anything. There are many ways. There are many ways to calculate this thing, right? So these are actually easy things. I hope it will be clear to all of you. And now let's move on to the next part. This is actually the energy of the traveling wave. Okay. So I hope that's all for today's. I'm gonna discuss this topic, which is actually the energy of traveling wave in the next class. And it is very important topic, because you have to know about the kinetic energy and the potential energy associated with the string. So be careful. So आज की क्लास में जो हमने सीखी about the calculation of velocity of transverse wave, like how to calculate, क्योंकि अभी तक जितने भी हम लोग कैलकुलेशन करते आ रहे थे ना, उसमें S इज इक्वल टू वी टी तभी तक अप्लाइड होगी जब वेलोसिटी ऑफ वेव कांस्टेंट होगी, जो आज हमें सीखने को मिला. If the velocity of wave is constant, तब s is equal to bt is applicable. अगर वेरिएबल है तो क्या एक्सेलरेशन कांस्टेंट है, एक्सेलरेशन वेरिएबल. तो so these are the things that we are gonna discuss in today's class. हमने कुछ प्रॉब्लम्स करी. So that's all for today. Thank you.